Assalamu alaikum everyone. Welcome to my presentation. My name is Ashik Islam and student ID is 20222 batch is 62. Today I will present a research paper. The name of this paper is Deep Analysis of Image Classification Architectures for Detecting Cancer Cells from Histopathological Images. This paper was published at IEEE International Conference on Computational Intelligence and Communication Network, CICN 2025. It was written by five researchers, Alisha Khan, Tauhid Bhuiya, Abdul Qadir Muhammad Masoom, MD Maruf Hassan, and Dawan Muhammad Farid sir. Let's start with the background. Cancer is one of the most dangerous diseases in the world. Every year, millions of people die from it. And the good news is, if cancer is found early, it can be treated. So early detection is very important. To detect cancer, doctors look at special microscopic photos of body tissue. These are called histopathological images. But the problem is checking these photos manually takes a lot of time. And the doctors can also make mistakes when they are tired and too busy. So this research uses AI to automatically check these photos and detect cancer. AI can do this job faster, more accurately, and without getting tired. This can also help in areas where there are not enough doctors available. Now, why was this specific research needed? Many AI models called CNN have already been made for cancer detection. But the problem is different models give different results. Nobody clearly knows which one is the best. So this paper takes five popular CNN models and compares them together on the same data. They focused on two common and deadly cancer. First one is lung cancer and the second one is colon cancer. The main question this research tries to answer are um, which CNN architecture performs best for lung cancer? Second one is which CNN architecture performs best for the colon cancer? And which model work for best for both and reliable? These are very practical questions that can help doctors and researchers in real life. Mm, Before doing new research, we need to understand what is still missing from previous studies. Most older studies only focused on breast cancer or skin cancer. They also tested only one model at a time, not multiple models like this one. Nobody had compared five models on both lung and colon cancer datasets at the same time. This is the gap, the missing piece. By doing this comparison, this paper helps researchers and doctors understand which AI model is truly the most reliable for cancer detection. This is exactly why this research is important and valuable. Problem and objectives. The main question of this research is which CNN model is best for detecting cancers from histopathological images. To answer this, the researchers had four goals. First one is compare five models VGG16, MobileNet V3, Inception V3, Exception, and DenseNet 121. The second goal is it test all five models on lung cancer images. The third one is evaluate all five architectures on colon cancer histopathological images. And the last one is identify the best performing architecture using accuracy, precision, recall, and F1 score. These four goals make the research very focused and organized. By the end of this presentation, we will have a clear answer to the research question. Now, let me explain what data was used and what this study covers. For lung cancer, there are 10,000 images, half are normal cells and half are cancer cells. For colon cancer, there are about also 10,000 images, again, half normal and half cancer. Both datasets were split 80% used for training the models and 20% used for the testing. The task is binary classification, meaning the model only decides between two options. Either the image is normal or it is cancer. The study also honestly mentions its limits. It only covers two cancer types and binary classification. Testing on more cancer types is something left for the future research. Uh, Literature review. This slide shows some important previous studies. For example, ABC Cambridge got 99.58% accuracy for breast cancer detection. Efficient Net V2 got 94.5% for general cancer. VGG16 was successfully used for skin cancer detection, and exception showed mm, strong performance on very large image dataset called ImageNet benchmark. These are all good studies, but they each tested different models on different cancer types separately. What makes this paper different is it compares five models on two cancer types at the same time. No previous study did this kind of complete comparison before. Uh, this is what makes this research unique and useful. Datasets. Now we will see dataset analysis. Both datasets came from a website called Kaggle, a popular platform where researchers share free data. The lung cancer dataset has 10,000 images, as I said before, half are normal and half are cancer. The colon dataset also has 10,000 images, also balanced between normal and cancer. Having equal number of normal and cancer images is very important. If one type has more images, the more model becomes biased and does not learn properly. Both datasets use 80-20 splits, where 80% is for the training and 20% for testing. This is very standard and trusted method for machine learning research. Now we will talk about data pre-processing. Before giving images to the models, the images had to be prepared first. This is called pre-processing. There are four steps. Step one is resize. All images are made the same size, 224 by 224 pixels. These standard size, all five models required. Step two is augment. Training images are slightly changed, rotated, flipped, or zoomed. This creates more variety and helps the model learn better. Step 3 is normalize. Image color values are adjusted to a standard range. This helps the model train faster and more smoothly to run. Step 4 is split. Data was divided into 80% and 20%, which 80% is for training and 20% is for testing. All five models received exactly the same prepared data. This makes the comparison fair and very trustworthy. Now let's look at the overall method of this study. The process is simple. Collect data, then prepare it and train each model and then compare all the results. The five models used are VGG16, um, which is very deep and simple design. MobileNet V3, small and fast. Inception V3 captures features at different scales. Exception, very efficient design. Dense 121, all layers are connected to each other. Each model was tested using five measures: accuracy, precision, recall, F1 score, and confusion metric. Together, these measures give a complete and honest picture of how well each model works. This section of the paper explains the five CNN models in details. Each model was chosen because it has different design and has proven to work well for image classification. VGG16 is known for its simple, deep design. MobileNet V3 is known for being lightweight and fast. DenseNet 121 is known for its dense layer connections. Inception V3 is known for mm, multi-scale features in extraction. Exception is known for being very efficient. And the goal is to find out which one of these different design works best for detecting cancer cells. Let me explain each model one by one. First of all, the first model is VGG16, and this is the best performing model in the study. VGG16 has 60 layers total, 13 layers extract features, and 3 layers make the final decision. It takes 224 by 224 images and uses small 3 by 3 filters going deeper and deeper layer by layer. The design is very simple and clean. It just stacks layers one after another in straight line. This simple but deep design is very good at learning detailed features from the images. In this study, VGG16 achieved the highest accuracy of 99.9%. 29.1% actually across both the datasets. Its simplicity and make it the most effective model for this type of medical image classification. This slide cover two more models, MobileNet V3 and DenseNet 121. MobileNet V3 is a lightweight model designed to work on devices with limited computing power, like mobile phones or small medical devices. It uses special techniques to stay accurate while using fewer resources. DenseNet 121 has 121 layers, the most in this study. Its special, uh, it is special design connects every layer to every other layer. This helps the model reuse what is already learned before. But here is a very interesting finding. DenseNet 121 actually scored the lowest accuracy of 90.6% in this paper. This shows us an important lesson. More layers and more complexity does not always mean better results. The right design for the right problem is what matters the most. Now let's look at the last two models, Inception V3 and Exception. Inception V3 has 42 layers. It is smart because it looks at the same image using different filter sizes at the same time. This allows it to catch both small details and big patterns in one go. This makes it very powerful and complex images like histopathological photos. Inception V3 came second in this study with 98.8% accuracy, very close to the first place VTD16. Exception has had 36 layers. It takes the same idea as Inception V3 but makes it more efficient. It separates the image analysis into smaller steps, which reduces the number of calculation needed. Uh, Here, both are very strong models and perform well in these comparisons. Now we'll see experimental setup and training pipeline. To make the comparison fair, all five models are trained in exactly the same way, same image size, same processing steps, and the same 80-20 rules for training and testing for the datasets. Same settings like learning rate, batch size, and number of training rounds also taken. This is very important. If one model was trained differently from another, the result would not be fair or very trustworthy. By keeping everything identical, we can be confident that difference in results come from the models themselves, not from the training conditions. Uh, this control setup is what makes the findings of this study reliable. Let me explain the five ways the models are measured. Accuracy. First one is accuracy. Mm, the percentage of correctly classified images out of the total tested serve as the primary benchmark for overall model performance across both datasets. It actually means how many images were correctly classified. This is the main measurement. And the second one is precision. Out of all images predicted as cancer, how many were actually cancer? High precision means fewer false alarms. The next one is recall. Out of all actual cancer images, how many did the model correctly find? This is very critical in medicine. Missing a cancer case can be life-threatening. And fourth one is F1 score, a combined score of precision and the recall. It tells us if the model is good at both. Last one is confusion matrix, a tabular virtualization of true positives and true negatives, false positives, and the false negatives, enabling granular analysis of classification errors. It means a detailed table shows exactly where model was right and where it made a mistake. Together, these five measurements gives a very complete and honest pictures of each model's performance. Um, Now we will talk about overfitting, handling, and generalization strategy. One important problem in AI is called overfitting. This happens while a model memorizes the training images instead of actually learning from them. The model performs great on training data, but poorly on new or unseen images. Think of it like a student who memorizes exam answers without understanding the topic. They fail when the question changes slightly. To prevent this, the researchers did three things. uh, First one is they carefully adjusted model settings like learning rate or and dropout. The second is they stopped training at the right time before the model started memorizing. Third one is they use transferable learning. This means the models already had knowledge from training on millions of general images. Then they were fine-tuned especially for cancer detection. These steps help all models perform better on new text images. And VGG16 showed the most stable and consistent result throughout the training. Um, Now, the most important part, the results. After testing all five models on both datasets, here are the average accuracy scores. VGG 60, which is scored 99.1%. This is the best one and highest average accuracy across both of the datasets. The second one is Inception V3, 98.8%, which is again very close to the first place. And the third one is Exception, around 97.6%. MobileNet V3 around 97.8%, and the DenseNet 121 is 90.6%, which is the lowest. The most surprising result is DenseNet 121. It has the most layer, like 121, but but it has the worst accuracy. This clearly shows that model complexity alone does not guarantee better performance. BGG16 is the clear winner. It's simple and deep design proved to be the most effective for this cancer detection. Let's look at the VGG16 detailed results. On lung cancer images, accuracy was 98.44% and F1 score was 98.91%. On colon cancer images, accuracy was even better. It's actually 99.69% and the F1 score was 99.35%. Mm, Meaning the number of the meaning of the number of mistakes was also very low, only 1.2% for colon cancer. These near perfect results on two different cancer types prove that BGG16 is not just accurate, it is also very consistent and reliable. In a real hospital setting, a model like this would seriously help doctors make faster and more accurate cancer diagnosis. Finally, let me give the conclusion. This study compared five CNN models on lung and colon cancer for the histopathological images. Here, the winner is clearly VGT16 with 99.1% average accuracy. Uh, it has beaten MobileNet V3 by 1.3%, DenseNet 121 by 8.5%, Inception V3 by 0.3%, and Exception by 1.2%. The reason VGG16 on is its simple but deep design, which is very effective for medical images analysis. For future work, the researchers want to test more cancer types, try multi-class classification, and explore newer models like Vision Transformer. That is the end of my presentation. Thank you everyone for watching. I hope everything was clear and easy to understand. If you have any question, I am happy to answer. So you can uh, let you type your question in the comment section. I will try to answer. It is